All right, so on 6-4, day 2, if you think about what we did yesterday we just did exponentials. That was it. What do you think we have today if yesterday we did just exponentials? That was a whole other chapter. What have we done in this one? Logs, right. So we're going to talk about the same type of things except for dealing with logs. There's 2 parts. The first part is going to be where we tell me the description that happens, so tell me the transformations, and then sketch the graphs. How many times have you done that for me? A lot. Then the second part of it is, here are the description, or here's what's the transformations, tell me the new equation. So there's nothing really new as far as the process go. The only difference is this time we have logs instead of not. So when you look at something like this, again, if you have f of x, if you have a minus on the outside, what's a minus on the outside tell you?
Reflection over the x-axis.
Reflection over the x-axis. Good. What's a times by on the outside tell you?
Vertical stretch or shrink.
Vertical stretch or shrink. I mean, really, do I have to write them down for you guys, or do you guys, I mean, because how many times have we done these? A lot. Then it's going to have log, and then with a base number. Okay. Now again, the base number depends on which way it's going to turn. For example, if that base number is greater than 1, that would be the reflection of exponential growth. So that's the one that comes up. If it's a fraction, that's the reciprocal, or the reflection of exponential decay, which would mean it would come down. Okay? That's the only difference there. Then if there's a parentheses, what's a negative on the inside of a parentheses tell you? Reflection over the y-axis. What's a multiplied in front of the x tell you on the inside? Horizontal stretch or shrink, depending on the number. Plus or minus, and then a number there. What's a plus or minus on the inside? Tells you left or right. And what's a plus or minus on the outside? I think that was up or down, but that's speaking yawn. So when you're looking at this, as compared to everything else we've already done, think about when we did the quadratics, when we did the absolute values, when we did the square root, when we did the exponentials, when we did all the other ones. Is there any difference in what we were doing? No. All of this is the same. The only difference that is there is that now you have log base. And you got to remember, if the base is higher than 1, it would be the reflection of the growth. If it's between 0 and 1, it's a reflection of the decay. That's the only difference. All right? Now, I did not write in there all the different pieces what it does, only because I think we've done it enough times where you guys told me every single thing that was going on. You guys know. All right? So here's the way your problems are going to look. It's going to say f of x equals log x. And g of x equals log, parentheses, negative 1/2 x. Again, the directions are going to be describe the transformations that take place, then sketch both graphs, or each graph. Okay? So, from the top one to the bottom one, what's changed? What's one of the transformations? Okay, I heard reflection in the y-axis. That's the negative part. Now what? Horizontal something. Horizontal stretch. By how much? Just 2. The negative was already the reflection, Jordan. So you were close. But remember, if that number is a fraction or between 0 and 1, that's a stretch when it's in the horizontal piece. Okay? Now for that particular thing, remember, anytime you have horizontal, you also have to report the reciprocal of whatever you're dealing with. So if it says 1/2, then it's 2. If it said 3/4, it would be 4/3, and so on. Okay? Now, as far as sketching them go, the one nice thing about this problem is when there's no base there, what's it understood to be? If I don't write a base number, it's understood to be what, Jordan? 10. Right. So could you type that in your calculator if you need be? Yeah. But because it's a 10, it looks something similar to this, where it goes to that ordered pair right there of 1, 0. Again, remember, anytime that number is higher than 1, it flows uphill. With your calculators, just so that you guys know, it never looks like it goes down forever. No matter if you shift it or not, it looks like it just starts in the middle of nowhere. And my only thought process, again, behind that, and I told you guys this the other day, but just in case you forgot, I think the only way that they do that, or the reason why they do that, is because it doesn't want to make it look like a vertical line in the bottom. Because if these are functions, then that would not pass the vertical line test. However, it looks like, bless you, it gets so far, so close to this thing, it is moving over slightly, but it just takes forever to get there, okay? And it's never going to get there. But just so that you guys know, it almost looks like a vertical line, even though it's really not. On your calculator, I think that's why they don't draw it, is because it would look like a vertical line, all right? So just so that you guys are aware of it, that does go down forever, all right? Don't trust your calculators on that part. Now, according to what you told me, to graph the red one, or the G, you told me to reflect it over the y-axis. Okay? So, if you think of this thing like this is representing the curve with my finger. Okay? With my hand, going like this. If I reflect it over the y-axis, or x-axis, y-axis, sorry, am I going this way with it? Or this way with it when it's x-axis or y-axis? No. The second one, I'm reflecting it this way. So instead of opening up to the right, it's going to open up to the left. Also, the other thing that's important to us, if this crosses at 1, 0, if I reflect it over the y-axis, it now crosses at -1, 0. And when I horizontally stretch something, that's like me taking it and pulling it this way, okay? Like Superman, all right? So does that really affect the graph a whole lot? No. It does affect it a little bit. It's supposed to go out faster, but realistically, are you going to see a noticeable difference? Not a whole lot. Okay? What do you guys think? Do you need me to do another one? Are you guys okay with it? Just remember, if you are shifting things, it's based on the point 1, 0. Okay, so if you have to go right or left, up or down, you base it off that point. Also, don't forget, the asymptote right now is the y-axis. So if you shift that to the right or to the left, you may need to draw a vertical line in there to have that asymptote look, if you need to. Do you need me to do another graph one? Are you guys good? Okay. Second part, and I know you guys have seen these many times before. It says, let it be a translation of 2 units up, followed by a vertical stretch of 2 to the graph log 1/3 x. I want the new equation. So we need to put the pieces in. Does it matter which one goes first? Yes. Because it says this one first followed by this one. When it says followed by, you got to make sure you put it in the right spot. So, what should come first? The 2. Where do I put the 2? And more specifically, the up 2, right? Where's up 2 go?
On the outside.
On the outside. Now, here's the thing. You might be saying, well, right now there is no inside. If you put +2 like this, that's understood to be outside. There is no parentheses. And when we mean by outside, I mean outside the x, which would also be this. If you were to put the x in parentheses, then that would be a +2 on the outside. If you put the parentheses around the x or not, that's your choice. okay? But just so that you guys know, if you don't have the parentheses, then that 2 that I'm put there is understood to be outside, unless there is a set of parentheses there, okay? Is everybody okay with the first part? All right. Now, the second piece, and this is the part that we've had a little bit of problems before doing because we just don't remember all of it. Where do we put a vertical stretch of 2 by? Inside or outside?
Outside.
Now, here's the thing. We put it on the outside of what we just created. Not the original one that we started with, but now we have an up 2 in there, don't we? So that thing needs to go around the entire piece. If you leave it like this, I am okay with it. However, what also could happen is distribute this out. What's 2 times the log 1/3 x? 2 log 1/3 x. And what's 2 times 2? 4. The 2 does not distribute into the x, just so that you guys know. It distributes into into all this. This is one big giant number. Okay, this is like saying one big y. So it'd be 2y plus 4. Okay, that's how it kind of works out. So it does not distribute inside the log, it just distributes into the front of the log. What do you think? Do you need me to do another one of these? Are you guys comfortable with them? I know you've done them many times, so I just want to make sure you're okay. Are you okay? All right. So when you look at your assignment, just so that you guys know, if you didn't write it down when you first came in, it's a pretty short assignment. On 27 to 29, it's going to ask you to describe what happens and draw both graphs. Then on 39 to 42, it asks you to write the new rule or give me the new equation.